Hey guys, want to do a couple of examples of graphing linear systems of linear equations with you guys just so that you can kind of see me do it before you get to work on your independent practice for today. So just like in the notes say, a system of equations is going to be two or more equations with two or more variables. So for now, we're only going to be focusing on two equations and two variables. So that's going to be x and y. So our two equations for the first example are y equals 2x plus 1 and y equals 1/3 x plus 1. We've got this curvy bracket thing, and don't be concerned if you can't draw it very well. It takes a lot of practice. But the purpose of the bracket being around the equations is to show that they belong together to create the system. So there are three different ways that you can solve a system. For right now, we're just going to focus on graphing them. So we're going to graph these two lines on the same graph, just one at a time. So first one is going to be y equals 2x plus 1. My y-intercept for this one is at +1, so I'm going to put my point there. And then my slope is 2, which is the same as saying 2 over 1. So that means I rise to run 1. So I can count up 2 and over 1 to get to there. And then I'm going to keep going so that my line is a little bit easier. I can also go down and over 1 in the opposite direction just to get that on there. And now I'm going to connect my points. It's going to be real important when you are graphing systems that you draw your lines all the way before moving on to the second one. I don't want you to get confused about having all of these jumbled up points on your graph and not knowing what connects to what. So make sure that you graph your entire first line first before you move on to the second one. All right, second one, again, we have our y-intercept of 1 here, and then my slope is 1 over 3, so that means I'm going up 1 and over 3. Then I can also go down 1 and over 3. So I'm going to connect those, trying to be as accurate as possible when I draw my lines. I think it's pretty obvious already where that intersection point is on this one, but in the future it won't be quite so obvious. But I'm going to take a colored marker and I'm going to circle the intersection point so that I can see. These have the same y-intercept, so that just happens to be the intersection point here, and that's going to be the solution for this system. But to write that out, we have to write what this point is. So my x value here is 0, and then my y value is 1. So the solution to this system is 0, 1. So really you just have to graph each line, observe where they intersect, write the coordinate of that point. And